Imagine this scenario. Maybe it sounds familiar. You're trying to roll out, I don't know, some new software, maybe even dozens of new servers, and you just find yourself doing the same repetitive steps, clicking the same menus, typing the same commands again and again. It's not just tedious, right? It feels like a recipe for mistakes, and it just burns through time you probably don't have. I think a lot of us in IT have been there, staring at that mountain of manual work. Welcome to the Deep Dive. Today, we're going to cut through some of that IT automation jargon. We're looking at a really powerful tool that's, well, it's genuinely changing how companies manage their whole digital setup. Ansible. Our mission really is to give you a shortcut. Not just what Ansible is, but why it's become so essential and how its design is actually surprisingly simple but powerful. We're going to pull out the key insights from our sources. So let's dive in. Okay, so to kick us off, for someone maybe new to this whole idea, what is Ansible at its heart?
Well, fundamentally, Ansible is an open source IT automation tool. Think of it like a tireless digital helper for your IT team. You know, it handles all that repetitive grunt work so people don't have to.
A digital helper. I like that framing.
Yeah.
And when you say grunt work, what kinds of tasks are we really talking about here? What does it typically automate?
Oh, it's incredibly versatile. It automates, well, everything from installing software, configuring servers, even orchestrating whole IT environments. You can use it for deploying applications, managing network gear, spinning up cloud resources, handling containers. You name it.
Right.
Ultimately, it's about making IT ops faster, yeah, but also just fundamentally more reliable.
Mm.
You know, slashing those frustrating little human errors that creep in with manual stuff.
Wow, that scope sounds
Ah.
huge. But for someone listening who maybe isn't deep in the IT trenches day to day,
Yeah.
how does it manage all that without being incredibly complex itself? Is there something in its design that makes it simpler? Or is it just, a really clever tool?
That's really where its genius lies, I think. And maybe a bit surprising how simple it aims to be. First, it uses these simple files written in YAML. They're called playbooks. And YAML is, well, it's designed to be human readable, almost like plain English instructions. So complex tasks become more accessible even if you're not a scripting wizard. Second, and this is really a game changer, it's agentless.
Agentless. Okay,
Yeah.
what does that mean in practice?
It means you don't need to install any extra software, no agent running on the machines you want to manage. All it really needs is secure SSH access, the standard secure login in Python installed on those remote systems. No agents means, well, less setup hassle, less overhead, and fewer things that could potentially break or need updating.
Agentless.
Yeah.
That really does sound different from a lot of older management tools. Like you're directly controlling things, not relying on intermediaries. Okay, so you've touched on simplicity. That leads us straight to the why. Why would an organization, or maybe even just an individual tinkerer, pick Ansible over other options? What are the big advantages?
Yeah, that's a key question for anyone evaluating automation. And that agentless thing you just mentioned, that's a massive plus. A lot of other tools do need agents installed everywhere. With Ansible, you just connect via SSH, run your tasks, and disconnect. That's it. It feels cleaner, and it actually reduces your security footprint, too. Fewer things running constantly.
Makes sense. And this simple YAML syntax you mentioned for the playbooks, how does that become a compelling reason to adopt it?
Well, it plugs right into this idea of infrastructure as code, or IAC. With Ansible, your entire setup, servers, networks, apps, it's all defined in these YAML files that are, like we said, pretty easy to read and write. This isn't just about making it easy, though. It means your infrastructure configuration can be stored in version control, like Git.
So you can track changes, review them.
Exactly. Track changes, audit who did what, roll back if something goes wrong, collaborate on it, just like software code. It kind of democratizes infrastructure management, makes it less of a black box.
Okay, that's powerful. Then there's this other term you hear a lot with Ansible, idempotent. Sounds a bit technical, maybe even magical. What does that really mean for the user?
Right, idempotence. It
Okay.
sounds fancy, but the concept is really about safety and efficiency. It basically means you can run your Ansible tasks, your playbooks, over and over again safely. It won't mess things up or needlessly redo work.
How does that work?
Think of it like a well-designed light switch. If the light's off, pressing the switch turns it on. Okay, simple. But if the light is already on, pressing the switch again doesn't, break the bulb or anything. It just checks, sees it's on, and leaves it alone. Ansible does the same. It checks the current state of the system first, and it only makes a change if that change is actually needed to reach the desired state you defined.
Okay. So it avoids wasted effort and more importantly, maybe prevents accidentally breaking something that was already configured correctly.
Precisely. Peace of mind, no fear of running a setup script twice and causing chaos.
Does that idempotency apply to most things in Ansible, or just specific parts?
It's a fundamental design goal for almost all the core modules that come with Ansible. They're built to work that way, ensuring things are reliable.
Okay, got it. And what about scale? Can it really go from managing, say, my one home server to, thousands of machines in a big company's data center?
Absolutely. It's designed to scale quite well, quite linearly, in fact. The nice thing is the complexity of managing your environment doesn't suddenly explode just because you add more servers. You just add more hosts to your inventory list, and Ansible can handle coordinating tasks across all of them. That's a huge advantage as you grow.
Right. And finally, you mentioned a huge ecosystem. What kind of power does that give someone using Ansible?
Yeah, this is where it gets really interesting. Ansible has this massive collection of what are called modules. Think of modules as pre-built tools or bits of code specifically designed to interact with different technologies. There are modules for pretty much everything popular out there. Cloud platforms like AWS, Azure, Google Cloud, container tech like Docker, Kubernetes, databases, network switches, firewalls, the list goes on.
So you don't have to write custom scripts for everything.
Exactly. This huge library of modules means you can automate interactions with all these different systems using the same Ansible framework and YAML syntax. It makes it incredibly versatile. You can automate almost any part of your IT workflow.
Okay, so we've got a good picture of what Ansible is, its core ideas like being agentless and idempotent, and why those are compelling reasons to use it. But to really make it click, maybe we can talk about some concrete examples. Where do people actually use this day to day? Where does it really shine?
Yeah, let's look at the practical side. One of the most common and maybe instantly understandable uses is server provisioning. Imagine you need to stand up, say, 5 new web servers. Each one needs the Apache web server software, PHP for the application, and maybe a specific database client. Instead of logging into each one manually, installing packages, tweaking configs, you write one Ansible playbook. You run it, and boom, all 5 servers are set up identically from scratch, probably in minutes.
Anyone who's done that manually knows how much time that saves and how many typos you avoid.
Oh, definitely. Huge time saver, huge reduction in errors. Then there's configuration management. This is critical. Say you have hundreds of servers. How do you make sure the configuration files, maybe security settings, application parameters, network settings, are all exactly the same and stay that way? Ansible excels at this. It can enforce a desired state across your entire fleet, ensuring consistency automatically. If a file drifts, Ansible can put it back.
Okay, so keeping everything aligned. What about getting software out the door?
Right. Application deployment. It's invaluable here. You can automate the whole process of rolling out new versions of your code, push updates to your testing servers, then to staging, then to production, all controlled by Ansible playbooks. Makes releases faster, more reliable, less stressful.
Less stressful deployments sound good. Well, what about the cloud? So much is moving there. And security, always a top concern.
Yeah, for cloud automation, Ansible is fantastic. You can use modules to talk directly to cloud provider APIs. So you can automate spinning up EC2 instances on AWS, configuring virtual networks in Azure, managing load balancers, setting up storage, all defined in your playbooks. Great for dynamic infrastructure. And for security automation, super important. Ansible can be used to systematically patch operating systems across hundreds or thousands of machines. You can use it to enforce security baselines, manage user accounts and permissions, configure firewalls, basically ensuring your system stays secure and compliant without someone having to manually check every single box.
And I've also heard it fits into the whole DevOps workflow and CI/CD pipelines.
Absolutely. In CI/CD pipelines, continuous integration and continuous delivery Ansible often comes in at the deployment stage. Tools like Jenkins or GitLab CI might build and test the code and then trigger an Ansible playbook to handle the deployment to various environments. It helps automate that whole path from code commit to running application, making the entire software delivery process smoother and quicker.
Wow, okay. That's a really broad set of applications. It touches almost every part of modern IT ops. Now, for anyone listening who's thinking, okay, this sounds genuinely useful, but how would I even begin to use it? Let's maybe walk through the basic steps conceptually. We're not expecting you to follow along typing commands, but just to get a feel for the initial setup. First off, where does Ansible actually run from?
Right, the practical start. You begin by installing Ansible itself, but only on what's called a control node. This is just your own laptop or maybe a dedicated server that you'll use to run the Ansible commands and playbooks from. The installation is usually straightforward. You used your standard system package manager like apt on Debian or Ubuntu, Yum, or DNF on Fedora CentOS, brew on a Mac, just a couple of commands typically.
Okay, so Ansible lives on my machine, the control node. But how does it know which other machines, which servers, it's supposed to talk to and manage?
Good question. You need to tell Ansible about those machines. This is done by setting up your inventory. An inventory is basically just a list of the servers, their IP addresses, or host names that Ansible should manage. Often, you'll organize these into groups in the inventory file. Like, you might have a group called web servers listing all your web server IPs, and another group DB servers for your database servers.
So you can target specific groups later. Makes sense.
Exactly. It lets you run tasks against, say, just the web servers, or just the databases, or maybe all servers.
And the connection itself. You mentioned SSH earlier. That's the key, right?
Yes, secure SSH access is fundamental. Your control node needs to be able to SSH into all those managed servers. And for smooth automation, you really want to set up SSH key-based authentication. This avoids having to type passwords all the time. Ansible can just connect securely using the keys.
Okay, control node setup, inventory defined, SSH keys in place. Now for the heart of it, the playbook. Let's imagine that simple example again. Installing and managing the Apache web server. What's the basic structure, the anatomy of a playbook file for that?
Right, so the goal is simple. Get Apache installed, make sure it's running, and ensure it starts automatically if the server reboots. A very common task.
So we'd create a file, maybe call it install.aml, because it's YAML. What are the main pieces inside, conceptually?
Okay, inside that file, you typically start with a name for the whole playbook, something descriptive like install and configure Apache, makes it clear what it does. Then you specify hosts.webservers. This tells Ansible, run the following tasks only on the machines listed in the web servers group in my inventory. Then often you'll see become. Yes, this is important. It tells Ansible it needs to gain root or administrator privileges on the target machine, like using sudo, because installing software usually requires that. And finally, the main part. Tasks. This is just a list of the individual actions Ansible needs to perform, one by one.
Okay, so under tasks, if the first action is install Apache, what would that task look like, conceptually?
So the first task would also have its own name. Maybe install the Apache 2 package, makes the output readable. Then you specify the Ansible module to use. For installing software on, say, Ubuntu or Debian, you'd use the apt module. Within that module's parameters, you'd say name, Apache 2, the name of the package, and state.present. Present just means make sure this package is installed. Wah. You might also add update cache, yes, to tell it to refresh the package list first, just to be safe. The apt module handles actually running the apt-get install command behind the scenes.
Right, so you declare what you want Apache present, not how to install it with specific commands.
Exactly, declarative. And then to make sure Apache is actually running and starts on boot.
So for the next task, maybe give it a name like ensure Apache service is started and enabled.
Here, you'd probably use the service module. You'd tell it name.apache 2, the name of the service, state, started, make sure it's running right now, and enabled, yes, make sure it's configured to start automatically when the server boots. Again, the service module figures out the right commands for the target OS to start and enable the service. You just declare the state you want.
That structure feels remarkably clear, actually. You're describing the desired end state. Okay, so you've written this install apache.aml file.
Yeah.
How do you actually, run it, make the magic happen?
It's usually very simple. From your control node, in the terminal, you just run the command Ansible playbook install apache.eml.
Just that. And what happens then? What does Ansible actually do?
It's pretty neat to watch the first time. Ansible reads your playbook. It connects via SSH to each server listed in the web servers group. For each server, it runs the tasks. It checks, is Apache installed? If not, it installs it using the apt module. Then it checks, is the Apache service running? If not, it starts it using the service module. Is it enabled on boot? If not, it enables it, all automated. And importantly, if Apache was already installed and running correctly, Ansible would just report OK for those tasks and make no changes, thanks to that idempotency we talked about.
That really brings the automation power home. Okay, let's just quickly peek behind the curtain one last time. How does this all connect? The architecture?
Yeah, stepping back, it's designed for simplicity. You've got your control node, your machine, running the Ansible playbook command. Then you have the managed nodes, the remote servers listed in your inventory. The link between them is that secure SSH connection. Remember, no agents needed on the managed nodes. When you run a playbook, Ansible connects via SSH and temporarily pushes small pieces of code, those modules we mentioned like apt or service, over to the managed node. The module runs there, executes the task, like installing Apache, gathers the result, okay, changed, failed, sends that result back to the control node, and then Ansible typically removes the temporary module files. It's a push-based system, very efficient, minimal footprint on the machines being managed.
And there we have it. It really crystallizes the surprising effectiveness of being agentless, the clarity of using YAML to define infrastructure, that crucial safety net of idempotency, and just how widely applicable this is across so many IT tasks.
Yeah.
It seems like it fundamentally shifts the approach, right? From hideous, error-prone manual steps to something reliable, repeatable, automated.
Absolutely. And whether you're someone directly managing systems day to day, or maybe just need to understand the tech landscape better, getting a handle on a tool like Ansible, well, it gives you real insight into how modern IT is becoming more efficient, more secure, just better run.
So wrapping up, what does this mean for you listening in? If Ansible can take something as complex as managing potentially vast IT systems and simplify it down to human-readable YAML files in this agentless approach, what does that suggest about other complex areas in our work or even life? Maybe the real takeaway isn't just about servers. Maybe it's about the power of breaking down big challenges into clear, repeatable, maybe even idempotent steps. Definitely something to think about until our next deep dive.